Good morning to all the students of classes 11 for the session 2020 and 2021. As you know that due to the outbreak of the coronavirus, the nation is going under the lockdown up for the period up to 14th April. So to compensate the educational loss or academic loss, we are going to start the video lectures for different chapters of physics of class 11. So during these lectures, you just need to have one pen and a copy in your hand so that if you found something important like important definitions or formula, you can note down. And also, if you have any doubt and queries, you can put it inside the comment below below the comment box in the comment box of this video, and I will surely answer you. So today we'll take the first chapter of the class 11, that is called the physical world. So before starting reading physics, first of all, you should know what is physics. So physics is actually the study of nature and its laws. Again, I'm repeating, physics is actually the study of nature and its laws. So we don't make laws for the nature. Laws are there in the nature. We just try to discover it and try to make their systematic study so that we can make interpretation that why something is happening. Like when apples falls down, for Newton, he discovers gravitation that day. It doesn't mean that gravitation starts from that day. Gravitation was always there. But Newton discovers that day means he got the answer of his query, why is apple falling down in place of going up? So that is what physics. Physics is actually the systematic study of nature. The second thing is, what is mathematics? Mathematics is actually the language of physics. Like you can say every content is having its own language. Like while you are reading computer programming, there are different languages: C++, Java, etc. These languages are used to make the functioning of computer easy. Similarly, the mathematics is used to make functioning of physics easy. So if you are good in mathematics, there is a very good amount of probability that you will move smoothly in physics. So you will need certain amount of understanding of mathematics so that you can have a smooth movement in the world of physics. So in the next chapter, we will study little amount of mathematics which will be required to study physics under the chapter named as mathematical tools. Okay, so the next thing is, as we know what is physics now, as we know what is mathematics, let's move into the physical world. From the time immemorial, people were just working hard to figure out that what are the building blocks of this nature, what are the things that actually consist this nature. So building blocks of the universe, people were always wondering. So first ever logical theory came into Greek mythology. They spoke about four things. The first one is fire, earth, water and wind. So these are the four fundamental blocks of everything what you have seen till date. You are made up of these four fundamental things. I am made up of these four fundamental things. This camera is made up of all these four fundamental things. And everything till date what you have observed is made up of these four fundamental things. Similarly, in Indian mythology, they have given one more element that is called space. So we finally come with the five things that we call the Panch Tattva. Chiti Jala Pavaka Gagana Samira, that is fire, earth, water, space and wind. So these are the five things they have created. Everything till date what you have observed is made up of these five things. But as the science progressed, people don't find this theory very logical, and then a man come into the picture named Democritus. Democritus proposed the word atom. Atom is something smallest. Atom means smallest. And then we have came with one first atomic theory that given by Dalton. So Dalton said, suppose you are having a piece of substance, and if you start subdividing it, then at a particular point you have to stop. You cannot go further, and that stopping point will be atom, the smallest unit. So in Dalton's concept, atoms are absolutely indivisible. So every element, doesn't matter whatever element you pick, and if you start subdividing it, you have to stop at one point, and that point will be atom. So that's why in all the Dalton's formula, atoms are always taken in the whole number because atoms are indivisible. Then one more man come to the picture named J.J. Thomson. Thomson discovered electron. So he actually discovered a substructure inside the atom, and that was the death blow to the Dalton's atomic theory, because he proved that there is something exists smaller than the atom, and we can take it out from the atom, and that was the electron. So then Thomson gave the first atomic model. In that model, he proposed that there is a positive base, solid positive base, over which the negative charges are embedded, and he named that model a plum pudding model. A pudding is a dessert and plum is a berry. So that dessert constitute the base, and then plums, the berries, are actually embedded, and these berries are negatively charged particles. In other concept, you can make a similar Example like a watermelon. Suppose you slashed a watermelon, then the red base is actually the positive charge and those black seeds are the negatively charged electron. So that theory given by Judge Thomson. Similarly, simultaneously, at that time, two students of Rutherford, Geiger and Marsden performed an experiment called the gold foil experiment. Actually, they have taken different kind of metal sheets or metal foils actually, and they bombarded the alpha particle on that, and they just draw some experimental data. It's experimental data. The most successful was the gold foil experiment. In that experiment, they observed that most of the alpha particles passed away the gold foil without getting deflected, and some get deflected through large angles, and 1 out of 10,000 or 8,000 get rebound back. And when Rutherford had seen those results, he finally came up with a theory called the Rutherford atomic model. And in that model is said that most of the part of the atom is hollow because most of the alpha particle actually crossed it without getting deflected, and all the positive charge and all the mass almost gets concentrated at the center, termed as nucleus, because out of 8,000, 1 get rebound back. That actually hits the it actually not hits actually going towards the nucleus, it gets rebound due to the positive repulsion. So that was the Rutherford's atomic model. In that model, actually, if I can simplify it, there is a positive charged nucleus contain almost all the mass of the atom, and then there are negatively charged electrons orbiting that positive nucleus, so in circular orbits. So that's what we call the Rutherford atomic model. So we are having two models simultaneously that time, Thomson's atomic model and Rutherford atomic model. Both models are having their own pluses and own minuses. I'm not going into details, but they're having their own pluses and minuses. Like the biggest drawback with the Thomson atomic model, it is not able to explain that Geiger-Marsden experiment. Second is, it is not able to explain those hydrogen spectrum. Similarly, in Rutherford experiment, the biggest problem is the question of stability of the atom, because we know from the principle of electrodynamics, whenever a charged particle accelerates, it actually loses energy. So whenever electron is orbiting, it should release energy, and so that its orbit will get shorter and shorter and finally get fell down into the nucleus. Actually, and if electron falls inside the nucleus, then atom is over. So then if atom is over, nothing will exist. So it's really make a question mark on both models. So then one more man come into the picture named Niels Bohr. So Bohr said, okay, I will study 6 months Thomson, 6 months Rutherford, and then I will come with a new atomic model. So actually, I hope 6 months he had studied Thomson and 5 months Rutherford. And then he come with his Bohr's atomic model based upon certain postulates. Postulates are scientific assumptions which needs not to be proved. The first assumption was that electrons are not allowed to move in all orbits. They can only move in those orbits for which the value of angular momentum is quantized. I'm sorry that for non-physics background people, angular momentum may be a typical term. I will explain it later. So the first concept was that electrons are not allowed to move in all orbits. They can only move into certain orbits. Just like that, you're driving a car on a multi-lane road. You are not allowed to go in all the lanes. You are only allowed to go in certain lanes, or one or two lane or 2 lane, which are permissible. The second concept was that while moving in a particular orbit, electron would not lose energy. So actually it fixes the problem of stability of the atom. And third was, whenever electron jumps from a higher energy orbit to a lower energy orbit, or lower energy orbit to a higher energy orbit, it either absorbs energy or releases energy, but only in integral multiplication of that energy packet called quanta or photon. Now, here you have to understand something that Mr. Usually student used to do that. Suppose this is a 5 joule energy level and this is a 2 joule energy level. So student thinks that whenever electron jumps, it actually jumps like normal anything, like something, you drop something. So suppose that if it is like that, then at any instant of time electron will be here, until it will reach the 2 joule energy. It means electron will be in all the energy levels between 5 to 2 at some instant of time, and it is not possible because Bohr said electron not allowed to exist in all energy states. It can only have discrete energy state. It is only possible if electron will disappear here and reappear here, disappear here and reappear here. That you have to understand. Similarly, orbits in are not some physical state. That doesn't mean that this is orbit number 1, this is orbit number 2. So electron jump from here to here. They are actually not geographical position. They are actually the energy states. Means while sitting in this particular point, if I'm having a 10 joule energy, I'm in a orbit X. If I'm having a 5 joule energy, I'll be in a orbit Y. That you have to understand. Now, after that, one more man come into the picture named Summerfield, and Summerfield actually makes a correction in the Bohr's atomic model. He said actually electrons doesn't move in circular orbit, actually they move in elliptical orbits. And then after that, Allenbuck and Gauss-Smith come into picture. They have proposed the vector atomic model. In that model, first time they have proposed that electrons not only orbit the nucleus, they actually spin. And that spin is not similar to the spin of the top. They are called the intrinsic spin. So the first ever the spin term is introduced is in the vector atomic model given by Allenbuck and the Gauss-Smith. And after that, Gell-Mann and Nishijima come into the picture. They have proposed the Quark model. What do you mean by Quark model? Is that say up to Summerfield model, you are having electrons orbiting outward, and then they are having a proton and neutron inside the nucleus. But so we are having 3 fundamental particles: electron, proton, and neutron. But Gell-Mann and Nishijima said actually what you are saying, a proton and neutron, they are not indivisible, they are divisible, and they consist of some smaller blocks called quarks. So they have proposed different kind of quarks. There are basically 3 sets of quarks actually exist on Earth: up quark, down quark, and strange quark. And then we have some quarks we found in cosmic radiation, that is charmed quark, and bottom quark, and top quark. So there are 6 quarks set. As we know, up to the quarks, so all the particles what we have figured out till date are broadly divided into 2 groups. One is called fermions, name of the scientist Enrico Fermi, and the second one is called bosons, name of the scientist Satyendranath Bose. So fermions are the particles which actually constitute matters like electron, proton, neutron, and bosons are the particles which actually constitute force like photon, graviton, etc. So, before going towards the forces, first of all, we need to remember certain things. That neutron was discovered by Chadwick, proton by Goldstein, and electron by J.J. Thomson. First atomic theory proposed by Dalton. Atom word was given by Democritus. First atomic model was given by J.J. Thomson, and the concept of spin was introduced in the vector atomic model, and the concept of quark was introduced by Gell-Mann and Nishijima. So let's talk about the forces. So there are 4 fundamental forces in nature. The first one is called the gravitational force. It is the weakest force in nature, and it acts between every 2 mass irrespective of their shape and size, and it depends upon their mass of the 2 objects and the distance between their centers. This force was discovered by, as you all know from the class 9, by Sir Isaac Newton. The second is called electromagnetic force. Electromagnetic force actually works between the 2 charged bodies. And then the third and the fourth are combinedly known as the nuclear forces. And the concept of nuclear forces is actually given by a Japanese scientist named as Yukawa. So Yukawa proposed the concept of nuclear forces because people were always wondering that what is the force actually which combines the neutron and proton inside the nucleus against their strong electrostatic repulsion. So initially people have thought that it's gravitation, but as we have calculated the strength of the gravitational force between 2 nucleon and the electromagnetic force between the 2 nucleon, we found that it's almost 10 to the power 34 times electromagnetic force is weaker than the gravitation. So it is impossible for the gravitational force to combine the nucleus against the gravitation electrostatic repulsion. So Yukawa proposed the concept of nuclear force. He said the nuclear force is actually that agent which is actually combining these 2 nucleon or nuclear particles of the nucleus against their strong electrostatic repulsion. He proposed certain properties of the nuclear forces, that like nuclear forces are short range, they are up to the 10 to the range of the 10 to the power minus 15 meter, means outside the nucleus there is no existence of the nuclear forces. Second, that nuclear forces are always attractive in nature. And nuclear forces are saturative, means nucleus only exert nuclear forces on their closest neighbors, and it is a non-central force. So these were the concepts given by Yukawa. One more force is nowadays comes into the picture, that is called Higgs Force. It still have to be proved, but in the recent discoveries of science, Higgs Force as proposed by Peter Higgs. Higgs Force is actually said that in the world there is a field called Higgs field, and this is the force actually responsible for the mass of every particle. So every particle in the universe is having mass due to the Higgs force. So this is the basic idea of the physical world. So from the next classes we will go